Okay, welcome to my lecture on binary and introduction to binary. If you're not already a part of my followers, you'll see a sign down here to click subscribe, please, so that you can join us in future lectures and you can also be helped with your maths. Right, let's have a look at this. What we have here in front of us is the conventional numbers that we know. We call those base 10 numbers. 0 is also one. I see it's not listed there, so it would be 0 as well. Okay, so 0 to 9 basically are our base 10 numbers. Numbers are made up out of those. For instance, you could have 28. That would be made out of a 2 and an 8, and as you know, that's 2 tens and 8 units. So we understand this work well enough. Those are our base 10 numbers, also known as the decimal system. Not decimal numbers, the decimal system. Right, so what is binary then? Well, binary is made up of zeros and ones. We call those bits. Okay? Bit is actually a little word made up from binary digit. That's how bit comes about. So the zeros and the ones in binary are referred to as bits. Right, let's see the next slide. Now, binary is also known as base 2. Like our digits for the normal ones we use are known as base 10, like our 0 to 9. Binary is known as base 2. Okay, that's just some terminology for you to know. And they use only 2 digits. Binary, base 2, only use 2 digits, and I'm sure you've guessed by now, it's 0 and 1. Those are the 2 digits that are used to represent any number in binary. Right, let's look at the next slide. So our conventional system has always used units, tens, hundreds, and thousands to display our numbers. You can see here we have 2,152. Easy stuff for you now by this stage in your walk in maths, but I just want to show you how it changes with binary. So basically, we were taught to break 2,152 up in expanded form like that. 2 of these thousands represent 2,000 plus 100 plus 50, which is 5 tens, plus 2. Okay, so that you're familiar with, and that is our normal decimal base 10 way of working with our numbers and with the regular headings we've always had. Now your headings are going to change for binary. Here they are here. You can see we start with 1. It doubled to 2. It doubles to 4. It doubles to 8. It doubles to 16, and so on. They double each time. Okay, those are our new headings. Okay, so let us look at what would be under this heading. If we had it in a binary scale, it would look like that. There's a binary number. It would mean one of these 32s, 0 16s, 1 8, 1 4, 0 2s, and 1 1. Okay, so now that you know that, don't worry if you don't understand it. We're going to work with it now and it will eventually just sink in. So there are those headings now, the ones we've just learned about our binary place values. There are our binary place values. Remember, you start at 1 and then you double each time for the headings of the place values. Right, so here we have a binary number. We would like to see what it's worth in its decimal form. So that would be the same as 164. So we write it here. Okay? And so on. 132. So we write it here. Okay? 116. So we write it there. 0 8s. So we write a 0. 0 4s. We write a 0. 0 2s. We write a 0. And 1 1. So we go write a 1 over here. Right. So far it is translated quite easily. This number is translating into whatever the result of this added up is. Okay, so 1 1 1 0 0 0 1, this number here, is going to come to a number once we've added these up in the decimal form. So let us go add them up, and we come to 113. So this number here is equal to 113 in our conventional numbers, our base 10 numbers. Okay, And that is the decimal base 10 version of this binary number here. So it's quite simple. Just to recap, if they say 1 of the heading, you add the heading. If they say 0 of the heading, you do a 0. But whenever you've got a 1, you look what it's above, and it's that, 16, you write it there. Okay, right. So now you know how to convert from binary to decimal. Now we're going to look at converting from decimal to binary. So let us try one. Let's try 13. So what we have to do, we have to say, using these numbers up here, which ones can we combine to get to 13? Well, we can say 8 plus 4, that gets to 12, plus 1, that gets to 13. Right, so let's write that down, 8 plus 4 plus 1. So we're going to put it here in binary then, 1, 8, 1, 4, 0, 2s, and 1, 1. So our number then for 13, as we worked it out, is 1, 1, 0, 1. Right, so then you can see that is quite easy enough. Now let's do 20. 20 we would probably add 16 plus 4, because that comes perfectly to 20. So now we're going to write on this line over here what we need to put in to get to what 20 would represent. So we want a 16 and we want a 4. So we're going to put 1 16, 0 8s, 1 4, and 0 of everything else. So the number for 20 would then be 1 0 1 0 0. Let's go write them down there in another color next to them. So 13 is going to be equal to 1 1 0 1. That's that number up there that we did. And 20 is going to be equal to 1 0 1 0 0. So it's quite simple to go convert from decimal to binary and from binary to decimal. I would recommend that you actually look at this video maybe once or twice again and then find some work to practice on. If you're not already following me, then you just click subscribe here so that I can help you in future classes. See you in the next binary lecture.